today we are going to discuss another Hackerrank problem named as Hackerland radio transmitter problem. Right. So it's a good problem. Let's quickly move to the problem itself. Okay. So this is the name of the problem. This is a small disclaimer. You can read it. Okay. Okay, so this is the problem. Let's say, let me put it above. Yes, okay. So the problem says that Hackerland is a one-dimensional city with houses aligned in an integral locations, right? So two, three important things here you have to understand. So first of all, it is saying that it is a one-dimensional city with houses at integral locations only. That means what? So let's say if this is a line, and if all the houses are there in this line, let's say this is our first house, this is our second house, maybe this is the neighbor of this, somebody close, somebody far, but every house has to be there at an integral location. Means, let's say this is at location 2, so this will be, let's say, at location 6, maybe this is at location 7, this is at location, let's say, 10 and 12 and something like this. But no house could be at location 2.7. Right? Fractional location is not allowed. That's the meaning. And all the houses will be on a single line, one dimensional, right? Okay, that I hope that's clear to you. Okay, so okay, and then the mayor wants to install radio transmitters on the roofs of city houses, right? So mayor want to install transmitter for a radio signal at the roof of every house. Okay, now each transmitter has a fixed range, right? Okay, so it cannot be a transmitter who can transmit for the entire city, right? It does not have so good range. So every transmitter has a certain range, right? So that would be same for all the transmitters, right? So let's say if one transmitter can transmit, let's say 100 kilometer, so every transmitter will be able to transmitting 100 kilometers, right? It's like that. Okay, so the range is fixed for every transmitter, meaning it can transmit a signal to all houses within that number of unit distance only. Okay, that's I think that's clear. Okay, next it's saying that given a map of Hackerland and the transmission range, so two things will be given in input. One is the map of the Hackerland, and second is the range of every transmitter. We have to determine the minimum number of transmitters so that every house is within the range of at least one transmitter. So the mayor wants to give, a radio transmission to every house, right? So, and he, of course, I mean, he want to minimize the total number of transmitter used for this purpose, right? So that the cost could be minimized, of course. Now, each transmitter must be installed on the top of some existing house only. You cannot make a house and then, install your transmitter on the roof, right? You have to, put your transmitters on some existing houses only. Okay, let's look at the constraints now. So the constraints are very, very big this time. Not that big, but fine. The constraints are, let's say, n and k will be from 1 to 10 to the power 5. It's huge. That simply says we cannot go n square, right? We have to be somewhere around n, or maybe at max n log n. We cannot go beyond that, right? So that's the constraint is saying. And the elements range is also very high. It's also 10 to the power 5. So ranges are quite good. I mean, that's we have to think when we are designing the code. Okay, so let's look at the input and output format. So in input, it's saying that the first line will contain two space separated integers n and k, where n is the total number of houses in the Hackerland, and k will be the range of each transmitter, right? Okay. The second line will contain the n space separated integers, where each of these integers will be representing a house at that particular location, right? X of I. And in output, we just have to print a single integer in a single line, which will denote the total, the minimum number of transmitter required for covering all the houses. Two, three important things. It's not saying that what if we cannot accommodate all the houses, right? Generally, this kind of problem also says that if you cannot cover all the houses, return a -1 or something like that. So it's not saying that. That simply means that anyhow we are going to cover all the houses, right? It's never be the case that we could not cover it. Okay. Okay, so let's see one example and try to make it more clear to us. So I have just taken the same example which is there on the Hackerrank. So the input is, let's say, 8 and then 2. So basically 8 is the value of n, the total number of houses in the city, and 2 is the range of every transmitter. They call it k and they call it n. So n and k is fine. Now these are the locations of houses. If you see it carefully, it's not sorted, right? So just to put all the houses on a single line, the first thing, I think it may have came to your mind also, the first thing we have to do is to sort these locations of houses, right? So once you sort it, it will become something like this. So it will become, let's say, 2 and then 4, then 5, then 6, then 7, then I hope 9, yes, 9, then 11, and then 12. I hope I have not missed 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Yeah, fine. So this is the sorted sequence once you sort it. Once you sort it, you can imagine it like this line drawn below, right? So the houses are at location 2. So there is the house, location 4, location 5, location 6, right? 7, right? 8, no, there's no house at 8, 9, and then 11, and then 12. So once we sorted it, we can imagine this as this line. So all houses are arranged in this line. Before I go to conclusion, let me give you 2, 3 important points which is hidden in this question. The first important thing which you should mark here is, it's not saying that we have to cover all the location. It is just saying that you put a transmitter so that we just need to cover all the houses. If there is no house at location 16 or 15 or 14, even it is a location in the city, I don't want to cover it. I'm not, if it is covered, that's fine, but I'm not interested in covering it, right? There's no meaning of covering because there's nobody living there. If there is a house, then only we have to cover that location. If there's no house, maybe at location 1 there's no house, so I don't have to think that I have to cover 1 also, right? So I just have to cover these locations where there's a house, right? Number 1. Number 2, I think it is clearly said in the question that we can only make, you can only put transmitters at the rooftop of some house. So that simply means these all are the candidates where you can put your transmitter, right? And then it says that the range of transmitter is also given. For example, in this particular case, it's 2. And the last thing is we have to optimize it, right? We have to, take the minimum number of transmitter required for this purpose, right? So those who have studied algorithm, they must be knowing that this basically problem belongs to a category of optimization problem, right? Let me write it here. It belongs to a category of optimization problem, right? Optimization problem. And to solve this, we will be using a very famous greedy approach, right? Okay, so having said that, let's try to understand the approach. You can pause this video right here and you can think now what approach could be suitable for this solving this problem, keeping in mind that we cannot go order n square time complexity solution, right? Because the constraints are 10 to the power 5, right? So we have to limit ourselves somewhere between order n, that is the linear time, and somewhere between order n log n only, right? So you can pause and think now. Okay, so if you have thought, then let me explain the logic to you, what we are going to do now. The first thing which must have came to your mind as well is where to put the first transmitter, right? So if the range of every transmitter is 2, what we will do, we will start traversing the sorted array. So let me write the sorted array once again. So let's say it's 2, 4, right? Let me write it quickly now. 2, 4, 5, 6, 7, 9, 11, and 12, right? So this is the sorted array. So what I'll be doing is I'll be starting from this location and I'll be adding the range to this. Let's say I is at this location. Then what I'll be doing is I'll be checking if I plus k is the range of each transmitter. So I'll be checking, and the best case is I can put a transmitter at k distance from this first house. So here the value of k is 2, the value of I is also 2, 2 plus 2, so it will be 4. So I'll be just saying, is there a house at location 4? Yes, in this case it is. So if there is a house, it's great. So you put your first transmitter here. Why? I hope it is clear to you, because by putting your transmitter here, you can cover 2, as well as you can cover very good 2 location. That is the maximum possibility in this side as well. So I just want to maximize whatever I can cover after this, right? If for this case, let's say, if for the case, let's consider that we don't have this 4, and instead of 4, let's consider 3. Then what will happen? So we don't have a house at 4. We wanted to, though we want to put the first transmitter at 4, but we cannot because there is no house. So in that case, what I have to do, I have to go back from this side and I have to find a house as close as possible to this 4, right? Why I'm going in this direction, I hope it is clear, because I want to cover 2. I don't want to leave it, right? So I cannot go beyond 4. If I'll go beyond 4, then the range is only 2 for every transmitter, then 2 will not be covered, right? So at max, what I can do is I can go up till 4. 2 plus 2, that is 4. So if there is no house at 4, let's say there's a house at 3, so in that case, I'll be going back and putting the transmitter at house number 3. But here, our good luck, right? And we have a house at location 4. So we'll be putting our first transmitter at location 4. And you can easily understand now, since we have kept a transmitter here at location 4, 2 location here in this side and 2 location here in this side will be covered by this transmitter because its range is 2, right? Okay, that's fine. So the next house about which we have to bother is this house. So now again, repeat the same thing, right? So where do we want to put the transmitter in ideal case? Again, I plus k. I is at this location, right? Now, okay, so 7 plus 2, 7 plus 2, that will be 9, right? So the ideal location here would be 9. And again, fortunately, we have a house at 9, right? Now I think you have understood. If we do not have a house at 9, we would have to explore this 8, right? Okay, so since here we have a house at 9, the next transmitter will be at this location 9. Now this transmitter will cover 2 houses in this direction as well as 2 houses in this direction. Now I have to bother this house about. This is the next house which is not covered yet. Now again, what I'll be doing is I'll be exploring I plus k. So here the value of I is 12, and 12 plus k, that is 2, so it will be 14. I'll see, is there a house at 14? No. I'll see if there is a house at 13. No, there's no house. So I have to put a transmitter here at 12. Once I put a transmitter here at 12, I'll see that all the houses are covered now. So I'll be terminating my program here. So I hope it make clear to you the approach, right? So if not, you can watch this video once again and it will make sense to you. I can guarantee that, right? So we are doing a greedy approach here. Let's see this particular test case. In this test case as well. So here what we do is, let's say here we have said that fine, we don't have a house at 4. So the first house is at location 2. We want to put the first transmitter at location 4, but there is no house at location 4. So what we have to do? We have to go back and we have to put the first transmitter at location 3, right? What we have just discussed. So it will cover this house at location 2, as well as it will cover 3, 4, 5. So it will cover this house as well because the range is 2 again, right? Okay. So so next, this is the candidate, the house at location 6. I have to think for this house. So for this, the ideal transformer will be 6 plus 2, let's say 8. And again, I have intentionally taken this test case where again there is no house at location 8. So what I'll be doing, I'll be going back, right? So again, so I'll be exploring for 7. Yes, we have a house at 7, so I'll be putting my transmitter there, and this transmitter will cover 2 houses in this direction and 2 houses in this direction. So 9 will be covered. That's fine. So the next house for which I have to bother is 11. So I can put a transmitter at 11, or the algorithm which we have discussed, according to that, the transmitter will be at the house number 12, but it doesn't matter because we don't have to return where we are putting these. Basically, we just have to return the total number of transmitter in the output, right? So here in this particular case, the output will be 3. So this is the problem at Hackerrank platform. Okay, so let's go to the coding part again. So I'll be selecting my Python 3 language here, and we have to complete this function here. The name of the function is quite big, right? So it says Hackerrank, Hackerland, radio transmitter, and 2 parameters are getting passed. One is X, that is the list of houses, or we can say location of houses, and the K is the transmission range of that of every transmitter. So let's make it a bit sensible, these variable. Let's make it let's say house or houses, maybe houses, right? And let's make this K as T range, right? Let's call it T range. Yeah, fine. T range, transmission range. Let's make it a capital T range. It will look good. Okay, so these are the two. Let's make it capital H. Okay, so now these variables are looking nice and making more sense, I hope, right? So this houses will be a list with all the locations for all the houses, right? And this T range will be the transmission range, right? Makes sense? Okay, so inside this, first of all, let us first sort the houses. So I'll be saying houses dot sort. So this will sort all the houses. The location of houses will be sorted out. Then I'll be initializing few variables. In output, we have to return the number of transmitter we require, right? Total number of transmitter we require. So for that, let me declare a variable transmitter count, right? T underscore count, COUNT count, transmitter count. And we will be initializing it initially with 0 because initially there is no transmitter, right? Okay, and for running a loop, let's initialize one variable I with 0. Now that's all about initialization. Now let's run our loop. So we'll be running a while loop until this I is less than the length of this list houses, right? So until then we will be running this loop. And what we'll be doing in this loop, do you remember? Yes. So first of all, we'll be calculating for the left path, and then we'll be calculating for the right path. So let's say first of all we can do transmitter count. We can increment the transmitter count later on once we find the location. So for that, let's call a while loop. So while, and we will be running this while loop till the maximum transmission limit, right? The left limit. So before running this while loop, let's calculate that maximum transmitter maybe range. Okay, let's make it capital. So maximum transmitter range from the left side. So how we can calculate it? So it will be the location of the current house, that is house of I. Initially it will be 0, right? So first house, location of the first house, plus the range, transmitter range. We have named this variable as T underscore range. So if we add this, do you remember the explanation? If we add this, we will be getting the range for the left side. So this will be the maximum range till what we can, we can do the transmission. Now, according to this range, let's run this loop. So this loop will be running until we reach to the length of these houses, right? So, and as well as we have to check for the maximum range as well. So this I should be less than or equal to the max transmitter range as well, right? So until these two conditions are getting satisfied, I'll be doing I plus plus. So I plus equals to what? So I'll be keep on incrementing I. So that's it. So once we find how far we can put I, we can increment our transmitter count. So we'll be doing T count plus equals to 1. It's done. Okay, so we have incremented our transmitter count. We found from the left side. Now let's see how far it can go to the right, right? So for that, let's call it so max or max T range we have calculated. So let's call it last T range. So for the current transmitter, what is the last range till what it will be there? So how to calculate the last range? Do you remember? Yes. So we'll be saying houses of I minus 1. Why minus 1 here? Anything? You can pause the video and you can think why minus 1. We have given minus 1 because if you see the first while loop here, in this while loop, we will come out of this while loop when it will cross the maximum T range variable, right? Because we are running till it is equal to T range. Can you see this? Less than or equal to. So until it is equal to the maximum range, the loop will run, right? So when I will be incremented and going beyond that, then we will be coming out of this loop, right? Make sense? Okay. So that's why here for calculating the last transmitter range, we have taken house of I minus 1 plus the transmitter range. So we call this variable as T underscore range, right? So this will give you the last range value. And after calculating that for the right side, let's run another while loop here. And we will say that we will run this loop until I's value is less than the length of, these list houses, right? As well as, so, okay, length of houses. Oh, we have two closing brackets. Okay. Oh, one is for the while loop. Okay, that's great. And as well as this I has to be less than or equal to this last T range as well. So until then, again, what I have to do? I have to do I plus plus, right? So I plus equals to 1. So it will keep on incrementing I. So that's it. And once we will be knowing the last range, we kept the I at the last range, right? And then we will be keep on doing it again for the next iterations, right? Make sense? Okay. So that's it. After doing all this, we will be returning the total count. We are storing it in T underscore count. So T underscore count. This is what we will be returning. Let's test our code. Okay, let's see. Oh, it shows some error. Let me see what's wrong going on. So let's see what's the error. So, oh my God. So here we have just written I. The loop has to go until that the location of the house should be less than this. So we should be writing houses of I. Yes, houses of I, as well as here as well. So here also I have to write houses of I. Okay, let's run this now. Oh, there's another error. Okay, index out of range. Let's see. Oh, okay. So in this while, oh, we should be going until I is less than length of house. It should not be less than equal to the length of house. Okay. So and both the loops I have changed that. Let's see. I hope it should work now. Oh yes, it worked. The sample test case is passed. Let's try to submit and see what's happening. Okay, boom. So all test cases passed. So I hope it makes sense to you and you have understood how to solve this problem, right? So we will meet again